Hello, let's continue our Sudoku adventure with Ace of Cups by Jean. So we have standard rule set today. So at least it's standard if you're familiar with them. So let's go over the rules. There are normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have region sum lines. That's these blue lines. So the way these work is you look at how when they cross bold borders into another region, a box region synonymous. So as they cross these bold borders, what we're doing is we're segmenting the line. So this is a segment, and then it segments here, and it is branching here, but this is a segment, and then it crosses through here, and this is a segment. So we kind of have 3 segments here, like this segment, this segment, this segment. Each segment of the line has the same sum as each other, as long as they're on the same line. So, these two add to this one, for example, but that sum could be different than on this line. But within this line, every segment has the same sum. We don't know what the sum is. That's for us to figure out. Okay, in addition to that, we do have our standard crop key pairs. So white dots separate consecutive digits. So if this is a 2, this could be a 1 or a 3. They just have to be consecutive in some way. And black dots separate digits with a 1 to 2 ratio. Another way to put that is 1 is exactly double the other. So if this was a 2, this could be a 1 because 2 is double 1, or it could be a 4 because 4 is double 2. The order doesn't matter, just that 1 is double the other. And that's it. Those are the rules. There is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. So one thing I can say about this sum is, let's see, what can I say? The black dot and the white dot should do something. It feels important. One thing we can say is the sum is at least 6, because the minimum I could put in these 3 cells is 1, 2, 3, because you can't repeat it in a box. And so minimum 1, 2, 3, that sums to 6. So we are at least 6. And the maximum we could add to is probably dictated by this black dot here. Because if you think about black dots, one kind of convenient way to think about them is there's going to be one digit that's lower than the other. And that's going to be half of the high digit. Or another way to put it is the high digit is exactly double the low digit. So if the low digit were a 1, we'd double that to 2. If the low digit were a 2, we'd double it to 4. If the low digit were a 3, we'd double it to 6. If the low digit were a 4, we'd double that to 8, but there is no 8 in the puzzle. So our low digit is always a 1, 2, or 3. We don't know which cell it goes in, but the low digit is 1, 2, 3, and the high digit is 2, 4, 6. And so 3, 6 is the biggest I can put across this black dot, and that adds to 9. So our sum is somewhere between 6 and 9. So if we want consecutive digits doing that, the other thing I can say is because these digits are consecutive, the sum is odd. That's because we're going to have one even and one odd, and an even plus an odd is odd. So I'm saying it's 6 through 9, but actually it's only 7 or 9. So if our sum were 7, the only 2 consecutive digits that sum to 7 is 3, 4. And if our sum is 9, the only 2 is 4, 5. Putting a 4 on this white dot. Removing a 4 from this black dot means we can't do 2, 4. We also can't do 1, 2, because 1, 2 adds to 3. We know our minimum is 7. We're adding to 7 or 9. So there are no 2 digits that have a 1 to 2 ratio that add to 7. We can't do 1, 2. We can't do 2, 4. And we can't do 3, 6. So this is going to be 3, 6. We're going to add to 9, and that's going to be a 4, 5 pair. And our remaining 2 digits are 1, 2. I think one thing we could have done, now that I see how this worked out, is we could have said 1 and 2 do not go on either of these dots. Because it doesn't add. So a 2 would force the black dot to be either 1, 2 or 2, 4, which isn't, 3 is too low and 2, 4 is even. And a 1 on the dots would certainly force a 1, 2, which would be 3. So the 1, 2 ends up here, and then that probably resolves these as well. But anyway. So this adds to 9, and there is no 1 or 2 here. That's quite limiting. 3 cells that sum to 9 must contain 2 digits that are from 1, 2, 3, and 1 digit that's from 4, 5, 6. A good thing to remember. one kind of way to prove that is if you have 3 digits from 1, 2, 3, that's going to add to 6. That's not 9. If you have only 1 digit for 1, 2, 3, the smallest you could make it is 1, 4, 5, which is 10. So you're going to have 2 digits from 1, 2, 3. So this is going to be we can't put 2 digits for 1, 2, 3 here because there's a 1, 2 pair. So this is going to be one of them. This is going to be 1, 2, 3, but it can't be the 3. And then we're definitely going to have a 3 on here because we can't put another 1, 2 on here. So there's definitely a 3 on here. And then it's either going to be 1 plus 3, that's 4, so it's going to join a 5. Or it's going to be 2 plus 3, which is 5, and that's going to join a 4. So this is from 3, 4, 5. These threes, put a 3 down here. I wonder if I'm doing too much analysis when I could be doing something easy. Probably, but I think it's kind of fun. All right, I think that's what we can get out of this right now. So I think I want to think about this one now. So these 2 digits add to these 3, and there's quite a few dots on here. How's this going to work? These sum to an odd digit, but then this could be even or odd. So this is minimum 6. This is maximum 11. Is there something we can tell math-wise about what's going on here? I'm not sure. So, I mean, one thing we could say is the minimum being 6. 6 would be 1, 2, 3 here. So this would have to be a 1, 2 pair. In fact, this would be 1, 2, 3 exactly if we wanted that to be 6. And that actually works as far as I can tell. I'm wondering, actually, let's take a step back because I actually just looked at this white dot and look at our bi values over here. So this can't be 1, 2. That breaks this one. It could be 2, 3. It could be 3, 4. There might be a lot more options. It can't be 4, 5. But it could be 5, 6. Oh, okay. So it just can't have a 1 on it. This could be a 1 easily. All right. So I'm missing the next follow-up here. I mean, it probably is this then. So how do I want to think about this? Is this... So if this is the low digit, a 1 would force this to be 2, and then this would be 3. That's pretty clear. That's forced. If this is the low digit and it's a 2, we would double to 4. And then 4 could be with a 3 or a 5. Now 2, 4, 5 is 11. That would be our biggest. So we could still do 2, 4, 5. This would add to 11. This would be a 5, 6 pair. If the minimum was a 3, this would be 3, 6, 5, and that's way too big. So the small digit, if this is the small digit, it can't be a 3. Now I'm wondering if this can be the small digit. So what I'm going to do is I'm going to just transcribe this up here just so I remember what I had here. And now we're going to say this is the small digit on our black dot. So if this was a 1, that doesn't work. These would both be 2. If this was a 2, remember it's the small digit, so we double it to 4. And then 2 would go with 3 because or 1, I suppose. So we could be 1, 2, 4 adding to 7, or we could be 2, 3, 4 adding to 9. Both of those work. Now if this was a 3, we'd be 3, 6 here. That adds to 9. This could be a 2, and that would add to 11. So these are the options combined with these. So we can add 5 to here. We can add 4 to here. We can add 1, 2 to here. I don't know how much that helped. It has a lot of options. The fact that this can be 6 is actually kind of surprising. But yeah, 6, 2, 3, 6 does add to 11. Oh. But it actually can't be. Because if this was 2, 3, 6 adding to 11, that uses up the 6, and now we can't use the 6 down here. I wonder if there's some combined thing we can do that would be helpful. Oh, okay. Well, okay, so this can't be 6, meaning this can't be 3. So this has a 2 on it. Because it's from the 1, 2, 4. This is not 3, 6 ever. So this has a 2 on it, meaning this cannot be 2. I think that excludes this adding to 6 then. Yeah, if this was 1, 2, 3, actually, the 1 and 2 are gone. How is this going to actually add to 6? It can't, because it can't be. If this was 1, 2, 3, 1 and 2 are gone, the minimum we could make this is 7, 3, 4. So this can't actually be a 1, making this a 2, 4 pair. So that adds to 6. So we add to 7 or 10 or 11. And I think I have to stop there. One thing I noticed while I was trying to see if there was anything else to do, well, I was confused by this. This 3, 6 pair does remove 6 from here, and 6 can't be on here. So 6 is one of these two, putting 6 down here. I don't think that's... Noticing that earlier would have been super helpful anyway. Now, is there something about... So there's only two... Are there two possible? There's 3 possible sums, no. But no 2 or 4. Okay, one thing we can say is this sums to an odd digit. Because this is baseline 6, that's even, and this adds an odd digit to that. So this sum is odd. The only way for 2 digits to sum to an odd number is if one of them's odd and one of them's even. Well, 2 of our even numbers are gone, 2 and 4. So we have to have a 6 on here, or we won't be able to add to an odd number. Now, the 3 odd numbers we were adding to, remember this is 6 already, are just this 1, 3, 5. So not only is this 1, 3, 5, 6, but this digit here, I'm going to call that green, it goes in one of these 2 cells on this line, which means green goes in one of these 2. I don't know how helpful that is, but it's an interesting observation. Because the 2, 4 acts as a 6, and so does the 6 down here. And so then whatever this is needs to join this to add to the same amount. These 2 adding to this means this is at least 3. It can't be 2 or 4, so 3, not 4, 5, 6. Can this be a 1, 2 pair in actuality? I don't see why not. Okay. What am I missing? Is it this one? So this is also at least 3, and it's not 4, 5. So this is... Oh, it's not 6. This is a naked 3. Wow, okay. Yeah, this is at least 3 because this could be a 1, 2 pair adding to 3. And in fact, that's what it is, because minimum 3, it can't be 4 or 5, and it can't be 6 because of this 6 thing that I just noticed. So yeah, that was probably the next step. I probably skipped ahead. Anyway, so the 3 goes there. This is a 1, 2 pair. So neither of these can be 1, and this can't be a 3. So if these aren't 1, then this isn't a 1. Because remember, these are the same. Okay, all the evens are gone, by the way. 1, 3, 5 up here, which means this is even. 2, 4, 6. Wow, okay. Does this help me? The 1, 2 pair. We do need a 4 in this box, which goes in one of these 2. And so then the 4 is up here somewhere. 7 or... Wait, what did I do here? I forced a 3 here. Why? Why did I force a 3 here? Because that's what gave me a 3 down here. Oh, I just forced the 3 by placing this 3? I don't think I had the 3 marked here until I placed this 3, did I? I'm actually going to undo to see what the state of the grid was when I... Why did I have those 3s? So we know the sum is... Okay, we know the sum is 9. Right, okay, yeah, and I needed a low in one of these 2. Yeah, so that was the 3. So shouldn't that tell me... Oh yeah, I just know this adds to 9. Okay. For some reason I thought the sum was still up in the air here, but it's not. It's been so long since I did that logic. Okay, 2, 4 pair here. Oh, I need a 1. Okay, so where's the 1 in this box? That's key. 1's in one of these 2. So this has to be a 2. So now this has to be 2, 3, 4 in order to add to 9. That 2 actually gives us the 4 and the 2 here. 2 cannot be next to 5, so this is a 3. That makes this 3 and 6, because this one can't be the 3, right? So we get a 3 in the corner, deep tooting. There's a 3 up here somewhere, and I don't need the green anymore. All right. So let's keep cleaning up. This is 3 and 4. That places the 4 and 6 in this box. That can't be 3. These can't be 3. 1 would go with 2, 5 would go with 4 or 6. Okay, that's still open. So adding to 5 or 6, no 1 involved. So 5 would be 2, 3. 6 would be 2, 4. So there's always a 2 on here. Well, okay. Must be just missing some Sudoku here. This is a pair. This is 1, 5. This is a digit. This is 5. So that's 1. That's 5. That's our 6. That's 1. That's 6. We need a 1 and a 5 here. Okay. So this adds to 6, meaning we can't use the 3. So that's our 3, giving us 6 and 3. So now this is 2 plus 4 only. That has to be our 6. 6 goes next to 5. That's our 1. We get our 4 and 5, 2 and 1, 2 and 4, 1 and 2. That's a 4, 5, 1. This is a 5. This is a 2, and we're done. All right. So I think probably this would have flowed a lot better if after this, I noticed this had to be a naked 3, which would have given us the 1, 2 pair here, which would have significantly limited this sum. I wonder how, yeah, because I don't know. I wonder how much of the analysis I did here ended up completely necessary. It's an interesting formation though. Like the way this got restricted was kind of neat. Ended up this only being a 2-4 pair here, and then this getting duplicated down here turned out to be there. All right, cool. Well, I enjoyed that. Hope you did too. Let me know how you did. If you enjoyed it, why not leave a like, subscribe, and a kind comment below.